Welcome back, everyone. Today's project is a bulkhead power connector. This is a useful item for bringing main power into your project where people will have access to both sides of the connector. A cable continues off from the bulkhead into a locked enclosure where the main power connections are made. The bulkhead connector is built up from a Tripp Lite power cable that has an IEC C14 connector on it and two milled parts. The power delivery cable can easily be found of the desired length and correct plug for the region. Commercially available, there are main power modules that often have a switch and a fuse, but those have pigtails. Alternatively, there's this style of bulkhead connector from McMaster, but it has exposed terminals. Both of these styles of bulkhead connectors are meant to be installed directly onto a locked enclosure. I hope you find this project interesting. It's little details like this that really finish off a project. And when you can't find a simple item like this available commercially, it really makes you thankful to have the equipment necessary to manufacture one yourself.
When I have odd shapes like this, I'm trying to make a part around. I'll scan them on a flatbed scanner, import that image into SolidWorks, and create a sketch around the image. Then add dimensions to that, do my cuts and my extrusions. To verify dimensions and relationships, I'll 3D print the parts and assemble them. Even though the 3D printer is often slower to make a part, it doesn't require any interaction from me or any setup time. After any required tweaking, the parts are exported to Fusion 360 where the CAM operations are created. This is the cover plate that the C13 connector will go through. That connector inserts into the C14 connector that we're securing into position with the other piece. The cover plate squeezes the C14 connector into that second piece, also covers up any messy cuts through the panel. Following the adaptive clearing with the stubby 1/4 inch end mill, an 1/8 inch end mill is used to square up the corners and bore the 5.5 millimeter through holes for the screws. This is a Dremel wire brush mounted in an 1/8 inch ER20 collet. I thought it would work well to deburr the part and maybe also leave the part with a nice finish. It worked well to deburr the part. The first couple passes left a nice finish, but I kept going and it burnishing the part, kind of smearing the aluminum. I certainly didn't like the appearance. Later I sanded both parts and they look great in the end. These are 4.2 millimeter blind holes that will later be tapped to receive 5 millimeter screws. There's a lot of material to remove in the center of this part, and I want to plunge the end mill to its full length to start. The material is first drilled out with a 3/8 inch drill. Oops. When I step drill a 1/2 inch, I typically start with 1/4 inch, but this time I skipped it, and I ran out of spindle power as the drill bit was breaking through. When the spindle stalls and the tool continues to press into the part, the closed loop stepper motors notice the stall. Their fault lines are wired into the emergency circuit, and a Linux CNC performs the emergency stop. I finished drilling the hole manually using the pendant, re-indicate, and move on. No trouble drilling the final 1/2 inch holes. By first drilling those holes, we can drop this 1/4 inch extra long end mill to the bottom of the hole and start cutting the entire length of the hole immediately. No long, slow ram pin period. Of course, this is a 3D adaptive clearing operation using rest machining from the previous operations. This operation is fun with all the chips being made, and there's a few ways that maybe improve its performance. The first is to increase the no engagement feed rate. In my setup, it was set to the cutting feed rate, which was 22.5 inches per minute. This could easily be increased for this part to 100 inches per minute and treated as a rapid operation. If doing that, just have to be careful that chips are sufficiently cleared. Raising the part up in the vise a little bit more would help the chips to clear underneath of the part. These chips are 3/4 of an inch long, and when this operation gets going, it's easy to get behind on the clearing of the chips. The fog buster by itself doesn't have enough pressure behind it to clear most of these chips out. Eventually I hit the feed stop button to clear the mess. For an automated setup, a periodic air blast or a computer-controlled coolant position system like Tommy made on his Ironhead Machine YouTube channel would work well. I didn't leave any extra stock material with the 3D adaptive clearing operation, but the connector doesn't quite fit. This is a 2D contour operation as a spring pass, and after doing this, the connector fit fine. Finally, a quick chamfer operation on the mill and hand tapping at the drill press, and this part is done. I just want to show you how these parts go together. The cable on the left is essentially a computer power extension cable, and I cut one end off, leaving the IEC C14 connector and a long cable. I thread that through the first part, and there's a ring on the back side of that part that prevents the C14 connector from being pushed out. The plate on the front presses against that C14 connector and keeps it secured into that first part body. Finally, a normal computer cable can then connect to the bulkhead connector assembly. To mount the connectors to the machine cover plate, I print out a 1:1 drawing and glue that to the surface of the plate. Irregularly shaped sections are traced and holes are center punched. This material is steel cladded foam, and step drills work well for making clean holes through it. In addition to the power connector, I'm also adding an Ethernet connector. This Ethernet bulkhead connector has RJ45 connectors on both sides, so it's really easy to install. To trace the irregular shape hole, I'm using a carbide burr mounted to a Dremel. The glue that I use is a 3M spray contact adhesive. It's stronger than what's needed, but the residue comes off easily with some alcohol. And I'm finally mounting the new part. I never found one of these commercially. If you know of a source, please let me know. It doesn't take very long to make one of these, but if I didn't need to make one, it'd be one fewer part that I needed to make. And finally, the panel is installed back into the plant phenotyping or plant imaging machine. This was a fun project. I hope you enjoyed it. I learned a few things, and I hope you did too. Until the next video, thank you for watching.